Good morning, good afternoon, good evening, wherever you are reviewing this presentation in the world. This is Lecture 2 as part of Education 6403, Educational Hardware Systems. This week's lecture is going to be covering the history of computing and learning innovation. People ask the question, why am I starting with computing history and learning innovation? There's a contradiction of sorts in my messaging for this lecture. And it's a very simple reason. And it starts like this. Educational hardware systems is a combination of topics that you are going to be learning about throughout the semester. The topics go across the map. You're going to be learning about the fundamentals of what's inside a PC, network computing, internet computing, as well as some pretty innovative topics. But everything started before there was such a thing as an internet. Computing didn't start in the 1900s. Computing started before the 1500s. It actually started in the days of the abacus. And I'd like to go ahead and give everyone some kind of education as to the history of where math and science merged together and some of the fundamental concepts that education has taken and built upon this foundation to build not only technology, but the emergence of education and technology together so that learners can adapt in the classroom and take all these different, amazing ideas and use it to their benefit. But before we do that, I want to go ahead and discuss the class format. Being that this is week 2, and this is your first formal week of class, I want to go ahead and introduce you to how each week will flow. Each week you're going to see in your lecture, as you do this week, a set of announcements and feedback. There's some class announcements. I provide feedback to you each week as to how I feel the class is going, some key announcements, things that are due, things I want you to be aware of, things that are pertinent. Really and truly, if there's something that I'm concerned about, I put it there. If there are things that I think that should be aware of that are 2-3 weeks down the pike, this is where I would put it. Then each week, I put a couple of very broad questions out in the lecture. Now, they're not questions that you will see on your midterm. That's not the purpose of these questions. The purpose of these questions is to make you think broadly. What are the main themes you should be thinking about during your lecture? What are the things that you need to synthesize throughout the entire class to bring it all together? Then I do an intro to the topic. Now, for example, this week, I start with, what is educational hardware systems? Well, you assume that my purpose is to discuss what is computing history and learning innovation, but I actually start with what is educational hardware systems, as well as what is IT architecture. Now, you're probably a little bit confused here. Well, the reason why I do that is because I want you to think about this for a second of, computing history is a combination of all the things we will be learning about in educational hardware systems. If you look at the definition of IT architecture, as you read a little bit further in, It's a combination of all the things that you will be learning about as part of IT architecture. Educational hardware systems is more of a custom design spin with an educational context, obviously. IT architecture is more of the traditional textbook definition in the IT world. Now, once we get past the intro material, I cover the multimedia and lecture content. 90% of what you will find in my lectures is very abbreviated content. A couple of paragraphs of content that I will be writing. I will provide you a framework to look at. I will then provide resources, videos, textbook-based material, and instructional content that I'd like for you to read. Based on that, the content is between 90 minutes to 2 hours worth of content. Sometimes it will be me presenting a PowerPoint along with some video, and other times it will be other people presenting content. So for example, this week you're going to be having a lecture with about 10 to 15 minutes me talking, and then it'll be about 2.5 hours worth of lecture content about the history of computing. Now, the reason why I give you other people is because, frankly, my colleagues in the industry are much better at talking about it, and they are the experts. I know every one of the people that is speaking, and some of them have actually been my mentors over the years who have presented in these videos, and I would do them a disservice if I was the one to present. So I let them do the speaking, and I will provide the backup by presenting the content to you as part of the lecture and the framework to assist you in learning the material. Following the multimedia lecture content, I then provide activities and assignments. This is where you do the activities and assignments for the week. Assignments is usually your discussion forums. If there's a specific assignment, the cloud assignment, your paper, your midterm, this is where the specific instructions would be assigned here. But activities is usually reading the discussions, reading the articles that I've assigned to you. And, obviously my goal is to provide you these things. It's ideal that you read them because everything is fair game for the midterm and all these assignments. But it's up to you. You're graduate students. It's really up to you to figure out what's important to you and not. So that is the class format. And this is the format I follow each and every week. So now let's move into the lecture. In the lecture, I discuss about educational hardware systems. For the purpose of this class, I define educational hardware systems as educational hardware systems are the nuts and bolts that allow for software to run, students to access content in various formats, and the behind-the-scenes tools and processes that enable the primary and/or secondary instructional experience. So, I mentioned software, the nuts and bolts, the hardware, the software to run. Okay, so the nuts and bolts are the hardware, the software to run, students to access the content, the various systems, the networks, the topology, a lot of that infrastructure. That's a pretty broad statement because there's mobile, there's social, there's cloud, in various formats, because content isn't just one format now. It comes into multiple formats. And the behind-the-scenes tools and processes that enable the primary and/or secondary instructional experience. That's the protocols. Because nowadays, everything has to go through some form of protocol in order to operate. I don't know many systems that don't have some form of security on it. I don't know many systems that don't have some kind of connectivity to something not wireless. So educational hardware systems is a very broad definition. This is my definition. And as you take this class, I'm confident that every one of you is going to come up with your own definition of what educational hardware systems is. But take this definition, and think about it, and then compare it to the next definition of what is IT architecture, the traditional IT definition of how all the systems come together to make the systems operate. So IT architecture consists of the hardware, the physical boxes. It's a cloud system. It's the boxes that people access in order to run over the network. The protocols, the software, the procedures, the rules, the acceptable use policies. It's everything from the wiring schemes, the networks, the electronics, the hubs, the switches, the routers, you name it. It's the entire kit and caboodle, the enchilada, whatever term you want to use. Every organization has to come up with its own technology architecture. The term architecture in technology, sometimes you'll hear the term business architecture, enterprise architecture, and technology architecture, IT architecture. There's an interchange. In this class, we really focus on the IT or technology architecture because we're focusing on the systems, the software systems, and the hardware systems. And the hardware systems and software systems includes the network, includes the cloud, includes the mobile, includes the security. Anything that makes the communication capability, the interoperability between the software and the hardware is included. And even the policies that operate as part of that network. So that is really what we focus on in this class. Now, let's take a step back for a second. Schools have all these different components. They all operate as these well-oiled machines. But they had to start from somewhere. And the funny thing is, most schools, most government institutions and educational institutions are actually the ones responsible for the innovation of technology, the birth of information technology. Think about it this way. The internet was a combination of the Department of Defense and 4 or 5 universities. DARPA created the network protocol, but email was a collaboration between 4 universities sending messages between each other in California. That's something that people don't realize, but it was commercialized. It took 10 years to commercialize, but it was the government and the educational institutions who made it happen. If you've ever heard of the first PC, the first computer, the ENIAC, it was created at the University of Pennsylvania. Yes, a company like IBM took that idea, worked with the University of Pennsylvania, and most of these commercial companies work with the universities, and you'll always hear universities working with IT companies, MIT, Harvard, Columbia, because they take the talent from these universities and build these consortias to go ahead and get the innovation from them. This is where computing history is a very, very rich, path. So the IT architectures start really in the computing history. Now, in the videos that you're going to be seeing, this is a high level graphic. You're going to be hearing from many, many computing historians, and you're going to learn back from 3000 BC, starting from the abacus, and you're going to move all the way from the foundations of the internet. Like I said, this is a very high level graphic just to show you some of the high level topics that you will be learning about. I know this is a very long lecture. Digest this in increments. Take copious notes. There are websites out there. Some people that, I would strongly suggest if you wanted to search the internet for some of their lecture notes, Martin Campbell Kelly, Tim Bergen, those are some people who I know have some pretty good notes out there. There's, computinghistorymuseum.org, the Computing History Museum in California. They have a couple of outlines. These are some websites that have some pretty good stuff that is useful, for, I'll call them cliff notes of sorts, that you can use to capture the history of computing. There's plenty of timelines and outlines out there. This is one of the times where I say I don't like Wikipedia. Wikipedia is a great source because they do have great outlines as to some of the major events. Great journals, ACM and IEEE, Annals of the History of Computing. There's, in particular, 1996, there was a phenomenal edition of the 50th year anniversary history of computing. The editor was Tim Bergen. Tim is one of my mentors, so I know that Tim did a phenomenal job in creating a 50-year retrospect of the history of computing. That's a great source, but once again, that's before the internet. The period of the internet, it's such a fast period that 1996 to probably about 2005, 2006 is pretty fragmented. So when I break computing history up, it's history of the internet and history of computing. So when you're searching history of computing and then history of the internet is how you should break it up. And that's really how I would search beyond the videos. And the videos do that. So whatever in the videos, fair game for the midterm and anything you're going to learn. Beyond that, don't worry about. If you want to learn about any of this stuff on your own, more power to you. The lecture notes and the articles, that's fair game as well. This is really the high level content that you need to know. Now, learning innovation. When we talk about learning innovation, each one of these tools was created in a school. They started in the classrooms. They started in educational institutions. They weren't created in corporate America. They weren't created by the government. They started because of some manifestation in an education environment. There was a purpose, whether it was for mathematics, for science, there was a purpose. Usually it was a scientific or physics purpose to help move things along. But learning innovation led us to some of the most amazing capabilities. But as you look forward, internet, it was to help, communicate between schools. Cloud computing is actually known as grid computing. Technically, that's what it was called. Mobile capabilities were, created by Xerox PARC. It was created, people think it was by BlackBerry and Apple. It was actually created using transmitters and wireless signals and IEEE and ACM and all these standards were created at Carnegie Mellon and MIT and Harvard and all these universities, then adapted by these technology companies. IoT, a lot of these wearable devices were created at universities as part of healthcare projects, as part of different projects that had to do with mathematics and physics and science needs. So learning innovation really and truly is all about this timeline. And educational technology emerges because the tools that we see today as part of this outline help students advance and grow as consumers and of consuming knowledge. This is what you're going to learn in today's lecture. Now, hopefully you'll enjoy the lecture material. So I want to go for final thoughts. Reading supports the discussions. You have 3 articles, you have the videos. The discussion forum questions. You have 1 question, you respond to the question. That's the first couple of days. You only have to write a couple paragraphs, a couple quotes. Don't put any personal emphasis in it. Make it research worthy. Once you finish that, respond to 2 of your peers. You only have to write 3 responses total. And it will trigger after 3 responses that you've completed the assignment. If you do not write 3 discussion forum responses, you will not get full credit and it will not trigger. It is automated to trigger for Sue and I to be able to grade your response. Week 1 is to respond to the initial question. The week 2 capability is to respond to 2 of your peers in alternate threads. You can respond to your own, more power to you, but you're to respond to other peer threads as well. And hopefully you will do some research in your response to your peers, although you don't have to. But if you say the typical response of me too, I like this or I like that, without giving something that's substantive, that is not a qualified answer. Once again, content in the lectures and all multimedia is fair game for the midterm exams. I will provide an outline the week before the midterm, but all the multimedia that you were watching today, all the lecture articles, they are all fair game. So please read everything if you can. That's it. Hope you have a great week 2. And if you have any questions, please contact me.